Hi, hello, and welcome to homework video number 19. Thanks for joining. We are just so glad to have you. We're going to get started on the ones on the left-hand side with Google Classroom. This is a review of exponential equations and exponential functions. So on this first problem, this says given that 2 to the power of m equals 8 and 2 to the power of n is equal to 16, write down the value of m and n. Okay, so let's look at this first question first that's just looking at the value of m. What this is really asking us, 2 to the power of m is equal to 8. It's asking us how many times do I multiply 2 by itself to get to 8. So let's think about that. 2 times 2, let's multiply together twice, that only gives us 4, times another 2, 2 times 2 times 2, that is equal to 8. We had to multiply it together 3 times, so in that case, m will be equal to 3. Because 2 to the power of 3, or 2 times itself 3 times, is equal to 8. Now for this other one, 2 to the power of n is equal to 16, I'll show you another method to solve that as well. It's easy to do this, but if it was like to the power of 5 or 15 or 20, then it gets a lot harder to kind of logic through those. On this one, 2 to the power of n is equal to 16. You can see this, yes. 2 to the power of n is equal to 16. Okay, when we have an exponent that we need to get rid of or get by itself, remember, our inverse operation to the power of is logarithm, so this is where we use our circle method. So I started in exponent form, so I need to go to log form. Log base something of something is equal to something else. I use my circle method. I start at the base, so my base of the log is 2. I go across the equal sign to 16, and then I go back around to get to n. So log base 2 of 16 is equal to n. If I pop that in my calculator, log base, what was it, 2 of 16 is equal to n. So I got 4 there. So n is equal to 4. Well, let's see if that checks out. That means that if I multiply 2 times itself 4 times, I should get to 16. So 2 times 2 times 2 times 2. I pop that in my calculator, 2 times 2 times 2 times 2, that gives me 16, so that checks out. Okay, so my answer there is m is equal to 3 and n is equal to 4. So 2 different methods for solving that. Okay, this next part of this question says, hence or otherwise solve 8 to the power of 2x plus 1 is equal to 16 to the power of 2x minus 3. Now on IB questions, whenever you see the word hence means use your answer from above. It means whatever information you found in the question before is going to be applicable here. Okay, and that's true of this one. We see we have 2 different bases here, but they have something in common. They both can be to the power of 2, or 2 to the power of something. So I could replace 8 here with 2 to the power of 3. So 2 to the power of 3, replacing 8, is equal to, well, 16 can be replaced with 2 to the power of 4. So 2 to the power of 4, and then the rest of the exponent here. Okay, this is exactly the same equation, but now my bases are in common. Okay, if I have the same base, I can cancel them out. So then I can cancel out this 2, and I can cancel out this 2, and I'm left with 3 parentheses 2x plus 1 is equal to 4 parentheses 2x minus 3. This is a much easier equation to solve because we could cancel out our like bases. I'm going to continue solving this problem here because I know I didn't give you a ton of space. So I've got 3 parentheses 2x plus 1 is equal to 4 parentheses 2x minus 3. First thing that I'm going to do is distribute to get rid of these parentheses. So that gives me 6x plus 3 here equals distribute 8x minus 12. Now I'm going to combine my like terms. I'm going to subtract 6x on both sides. That's going to give me 3 is equal to 2x minus 12. Still not done combining like terms. I'm going to add 12 on both sides. 15 is equal to 2x. X isn't totally by itself yet, so I'm going to divide by 2 on both sides. So I get 7.5 is equal to X. Okay, and then that is my final answer there. 7.5 is equal to X. If I wanted to check double check that that was true, I could take 7.5 and plug it in for both X's here and see if the left-hand side equals the right-hand side. Alrighty, so biggest thing we see here is we can rewrite bases as a base to a power in order to cancel out like bases. Next section is on solving exponential equations, but here we've got a bit of a word problem. One thing I'm going to ask you to change first, I accidentally copy-pasted the same question twice. I'm going to ask you to change, find the number of bacteria in the colony at the start of the experiment. At the start of the experiment. Okay, so let's read this. The number of bacteria in 2 colonies, A and B, starts increasing at the same time. The number of bacteria in colony A after T hours is modeled by the function, and I've written it below. So T is in terms of hours, so we know that T is equal to hours. We know that A of T is equal to population. Okay, so this equation, I'll zoom in a little bit there. This equation models the growth of that bacteria colony, so we can use this equation to make predictions. Okay, first thing it says is find the number of bacteria in colony A at the start of the experiment. So at the very beginning of the experiment, time hasn't started yet, right? If I had a stopwatch, at the beginning of the experiment it would be at 0, and then when I started it, that was when we would start timing. So at the start of the experiment, T is going to be equal to 0 because we're at the very beginning before time has started. So let's take that. If I know T is equal to 0, I can plug that into my equation. Okay, so wherever I see a T, and I know it's really tiny here, but wherever I see T, I can plug in 0. So that's going to give me A of 0 is equal to 12e to the power of 0.4 times 0. Okay? And that's something I can pop directly into my calculator. I'm going to pop just the right-hand side into my calculator because A of 0 just means we want to know what is the population when time is equal to 0. A of 0 is what we're solving for. So if I plug this into my calculator, I'm going to do 12. And then E is on the kind of left-hand side of the calculator here. Reminder, E is our one of our special numbers. It's like pi or something like that. So E to the power of 0.4 times 0, that gives me 12. So my answer is 12. So the number of bacteria at the start is equal to 12. Okay, next thing, it says find the number of bacteria in the colony after 4 hours. Well, that's another time. It's giving me another number for time. So T is equal to 4 here. We're trying to find A of 4 or the population. Okay, so let's plug in what we know. A of 4 is equal to 12e to the 0.4 times 4 here. Again, the only thing that changed between these two, I plugged in 0 up here because time was 0. I plugged in 4 down here because time was 4. So same thing, 12e to the power of 0.4 times 4. That gives me 59.43. So I've got A of 4 is equal to 59.43. So we could say after 4 hours, there's about 59 bacteria. I rounded down here because 0.43 isn't the number after the decimal isn't 5 or greater. Wow, had a brain moment there, sorry. Next one, how long does it take for the number of bacteria in colony A to reach 400? Now this is a slightly different question because it says how long does it take? So we don't know the value of T, right? We don't know the value of T, that's what we're trying to find. For the number of bacteria in the colony to reach 400. So I know that the population, or A of T, is equal to 400. So now let me plug in what I know. Okay, well I know A of T is 400 is equal to 12e to the power of 0.4t, and t is the value that I'm trying to find. Okay, so I'm actually going to continue this problem on a blank sheet of paper so that I have enough room. So I've got 400 is equal to 12e 0.4 to the power of 0.4t. Well, if I'm trying to solve for a variable, I'm always going to use SADMEP, or my reverse order of operations. First thing I check for is addition or subtraction. Don't see any here. Next thing I check for is division or multiplication. I do see some of that here. I'm going to divide by 12 on both sides. 400 divided by 12 reduces to a fraction, 100 over 3. Oh, and 12's gone now, sorry. Whoops. 100 over 3 is equal to e to the power of 0.4t. Okay, so I check for division and multiplication. Next thing I have is an exponent. Well, I do have exponents here. Okay, so what I need to do is cancel out my base so I can get my exponent by itself. That's, again, where we're going to get to circle method here. So I have it in exponent form. I need to translate it or convert it to log form. I start with my base of e, and I go across the equal sign. So log base e to the 100 over 3, and then back around to my exponent, 0.4t. Okay, well, t isn't totally by itself yet, so the very last thing that I need to do is divide by 0.4 on both sides. Those will cancel. I'm going to pop this into my calculator. So I've got log base e of 100 divided by 3. All of that over 0.4 is equal to 8.766. So t is equal to 8.766. So if we know that t is equal to that, we can say after about 8.8 hours, there will be 400 bacteria. Okay, again, we're solving for an unknown, but that time we were given the population and asked to find the time instead of given the time and asked to find the population. All right, last one here. The number of bacteria in colony B after 10 hours is modeled by this function. Wow, that's really hard to read. I'm sorry. Let me rewrite that here. B of t is equal to 24e to the kt. Okay? After 4 hours, there are 60 bacteria in colony B. Find the value of k. Okay? So this is really important that we label our variables correctly here. After 4 hours, that means t is equal to 4. There are 60 bacteria in the colony. So B of 4 is equal to 60. Find the value of k. So let's plug in what we know first. I know B of t is 60. 24e to the power of k we don't know, but we do know t. So plug in what we know. And again, I'm going to go over here to solve because I don't have a ton of room. I've got 60 is equal to 24e to the power of 4k. Again, when I'm looking to solve or get a variable by itself, I'm going to use reverse order of operations. I don't see any addition or subtraction here, but I do see multiplication, so I'm going to divide by 24 on both sides first. 60 divided by 24 is going to give me 2.5 equals e to the power of 4k. So I did my division and multiplication. Next thing I need to check on is getting rid of my base so I can get an exponent by itself. I'm going to use circle method here again because I have an unknown in my exponent. So I should get log base e of 2.5 is equal to 4k. K isn't totally by itself yet, so the last thing we're going to do is divide by 4 on both sides. I'm going to go ahead and pop that into my calculator. I'll get log, oops, that's not log, that's log, base e of 2.5, all of that over 4, and I should get 0.229. So k is equal to 0.229. I can round that to k is equal to 0.23. Okay, so these questions solving-wise aren't super hard. It's just you have to remember to put the correct variables or read the question and plug in the correct numbers for the correct variables. All right, that is it with exponential equations. We are going to move on to some trig functions here. I'm actually going to teach you about one or two new things here when we're talking about trig functions. So first thing we want to look at is some transformations that we have here. Let f of x is equal to 3 sine times pi x. Write down the amplitude of f. Well, this actually has to do with our transformations. If you'll remember, our transformations look something like this. We'll keep it with the same letters that they do, qx plus r. P is your vertical stretch, or vertical compression. So P changes your amplitude. So P is equal to your amplitude. So whatever my value is in front of sine is going to be my amplitude. So my amplitude here is 3. Because P, the value in front, is our vertical stretch, whatever number is in front here is always going to be my amplitude. Next thing we're going to look at is find the period of f. Well, Q is the value that changes the period. Okay, Q is the value that changes the period. And all we talked about with Q is whether it made it horizontally stretched or horizontally compressed. But we can actually find out exactly what it makes the new period based on what we know about the period of the parent function. The period of the parent function is 2 pi. Right? The period of the parent function is 2 pi. It repeats, the function repeats every 2 pi units. Okay? So what we can do is we can take the period of the parent function, which is 2 pi, and divide it by our q value. We can divide it by the transformed period of our new function. So this is actually a pretty easy one. If I have a pi on top, pi on bottom, those are going to cancel. So I know my period for this function is 2 units. Okay? Is 2 units. Okay, on the following grid, sketch the graph below. So if we're looking at this, I know what my amplitude is and I know what my period is. I always sketch my parent function first because I find that, I like to think about my parent function first. That helps me sketch the function. So I know that my parent function usually has an amplitude of 1 and it repeats every 360 degrees or 2 pi units. So what I want to look at here, I know mine's going to repeat every 2 units. So my function has to repeat, or the period is going to be from here to here. This is going to be the new period of my function, and there are 5 points that I have to plot. For my sine function, it goes 0. For the parent function, it goes 0, 1, 0, 0, positive 1, 0, negative 1, 0 again. That fits within my period of 2 for this function. So I know I'm going to have an x-intercept here, an x-intercept here, and an x-intercept here. Then my function will repeat through 3, because it tells us we have to plot it all the way to 3. Okay, the amplitude of the function is at 3. So usually my amplitude is at 1. I'm going to bump it up to positive 3 here, negative 3 here, positive 3 here. And that should give me a sketch, a rough sketch of my transformed function. I know the period's the same. It repeats every 2 units. If I wanted to, I could plot it to here and up to here. It's restricted me to only plotting it to 3, but that would help me see that every 2 units my function repeats. And then I know my amplitude changed to 3. The biggest thing about this is we have to remember that the parent function of a sine graph goes something like 0, then it goes up 1, then it goes back to the x-intercept, down 1, up 1. Okay, those 5 key points are really essential when you're sketching functions like this. All right, very last one that we are going to look at. We've got another transformation one here. Remember, like I wrote up above, P changes our amplitude. Okay, Q changes our period, and R changes our vertical shift. When it's positive, we know that we're moving up. It's positive, we know that we're moving up. Okay, this just asks us to find the value of P, Q, and R given this function here. Well, let's label some points that we know first. I see that my maximum value is at 1, 5, and I see I have a minimum value at 3, negative 1. So these are 2 key points here. when I'm trying to figure out things like my period or my amplitude or my vertical shift. So when we're looking first at the value of P, we're looking at our amplitude. Remember, one way that I taught you to calculate amplitude was you take your highest Y value, or the Y value of your maximum, minus the Y value of your minimum, divided by 2. So Y value of the maximum is 5, minus the Y value of your minimum, -1. Divide all of that by 2. So these are on the top, it's the Y values of the max and min. Okay, so that'll give me 6 divided by 2, which is 3. The amplitude of my function is then 3. Okay, well for Q, that's going to be the period of the function. This one gets a little bit trickier when we're talking about the period of the function. The way that I figured it out is I said, okay, well, I know what this point is. I know what this point is. Let me see if I can figure out R so I can plug it into my original equation. So I'm going to look at my value of R next because I know that's my vertical shift. If I'm thinking about the parent function, I know that my parent function has an x-intercept at 0, 0, right? So I see that on this actual function, my x-intercept, my first x-intercept at 0, 0 shifted up 1, 2 units. So I know my value of R would be 2 because I started at my x-intercept from my parent function. You could call it your y-intercept as well, and I shifted up 2 units from that. Okay, so now that I know the value of R, let's see what I can plug into this function and figure out from there. Okay, so I know that I can use this as an x value, I can use this as a y value, and I know the value of P and the value of R. So I'm going to write all that down and plug it into my equation that's given here. Okay, so I'm given this equation here. I see that f of x, it's the same thing as y, is equal to P sine of qx plus R. Okay, so let's plug in what we know. I know my y value is 5 because that is a point on my function. My p value is 3. Sine, my q value, that's what I'm looking for, right? Q, my x value is 1 plus my r value of 2. Now I'm going to try to solve for q here. I'm going to subtract 2 on both sides. I get 3 is equal to 3 sine of q times 1. Q times 1 is really just q. Divide by 3 on both sides. 1 is equal to sine of q. Okay, well, there's a couple different ways we know how to solve this. Based on the unit circle, this question is asking us what is my degree measure when my x value, because sine is y values, excuse me, when my y value is equal to 1. Because sine is our y value, so what is the degree measure when my y value is equal to 1? Well, for sine, that's at 90 degrees. So q is equal to 90 degrees. Well, if this function repeats every 90 degrees, let's compare that to the parent function. This is the transformed function. It repeats every 90 degrees. The parent function repeats every 360 degrees. So the difference there is a factor of 4. The way I can figure that out, like we did in the example problem up here, we did the period we know divided by the period of the transform function. 360 divided by 90 gives me 4. Okay, so my q value here is 4. Another much simpler way to figure that out, so we know the function repeats every 4 units. Well, I could start here at -1 and see how long does it take until the function repeats itself. I get to +3. That's a total of 4 units. If I start at +3, how long does it take for the function to repeat itself? Well, it's at 7. That again is 4 units, so my period is 4 units. Okay, that is everything for homework video number 19. Question, comments, or concerns, come chat with me. As always, like and subscribe.